In today's note, we're going to continue our discussion of surface area of three-dimensional shapes, and today's focus is on cylinders. So once again, we are discussing the surface area. That means that we are covering our cylinders, and we're still doing the area in square units. So cylinders have two bases that are circles, they're circular, and one carved lateral surface. So just like when we were working with nets, you saw how that surface, this cylindrical surface, wraps around the can or any kind of cylinder just about. So the height of any cylinder, once again, is going to be the distance between the two bases, as we are observing right here. So as before, our focus right away with identifying where are the bases, where's our height, so we can start breaking down all of the information about our shape. So as you can see, it says if the cylinder were unfolded into a net, the circular bases are becoming circles, and the lateral face is a rectangular shape. It becomes rectangular when you unfold it. So from our previous experience, when we look at this shape, we would say this is base times height. This is just simple rectangle. I'm going to come back to it in just a second. So it wraps around right here. It's that shape that's going to be between the bases. Base is a circle. So we are looking for the radius measure, or I'm going to draw it this way, diameter measure. We could have either measurements in those bases. And since we are discussing the area, I'm going to go ahead and write the formula that we're going to be using. It's pi r squared. So the formula for lateral surface area and total surface area listed right here. So I'm just going to highlight our box. And as before, please do not memorize the formula. Do not try to stress over memorization. But I do want for us to kind of talk about what are we seeing and what do we know about this formula, and why all of a sudden this lateral surface area turned to be this collection of variables. So your base times height, this rectangle, is truly has to be seen in a cylindrical application. So as before, I'm going to just use my little example right here. So that's what, when we say the lateral surface unfolded, you would be it's surrounding your can or whatever container you're working with, and then you unfold it, and it is a rectangular strip of paper or material. So if you take a closer look right here, 2 pi r is the same as circumference. So circumference wraps around the base. So since it's all about circles, they are keeping it in that circular formula format. And so the h, hopefully h makes perfect sense. H is the height between the bases. So for our quick comparison, last time we talked about surface area of prisms, and we did say, we did have a discussion about perimeter. Well, is circumference a perimeter of circles? Yes, it is. So I hope you've seen it's absolutely the same application of the concept. This is the distance around the base. And so when we look at the continuation, the total surface area, we would say it's lateral area. What do we see? It's the same formula. The same formula for lateral area is in the front of our total surface area. So we would say lateral area plus 2 pi r squared. So we talked about this earlier. I wrote down the formula right here. 2 areas of circular bases. So in our, again, compared to prisms, we found the area of a triangle or area of rectangle, and there were two bases. So we added them together, multiplied by 2, and then added to the lateral area. So I hope you are observing a lot of similarities. We are still keeping the formula true to the circles. So you've seen the pi and r and so on. What I like about this formula is that you do not need to do any guessing. So let's actually put this to work so you hopefully see the true application of the formula. So we have a cylinder here, and as always, our step 1, let's identify our bases. Okay. So the unique concept of the height, we addressed this few times last week. The height is the distance between your bases. No matter how your shape is behaving, this is still the distance between the bases, aka the height of the shape. All right, let's get to work. So we need to find lateral surface area, so it's going to be 2 pi r h. These variables are being multiplied. That's how algebra shows multiplication. Let's plug in 2 pi r, it's our radius, 6, and then 13 is our height. And when we multiply them across, we're going to get 489 and 8400ths square units. Okay, so no guesswork. You know what pi is, you see in your radius, we identify the height, we literally plug it in. For the total surface area, we know it's 2 pi r h plus 2 pi r squared. Again, I am saying it this fast only because I am looking at my formula right here and just copying it down. And so, as before, we can copy this number right here. That's our lateral area plus, and now we can plug this, the rest of the information. 2 times pi times 36. So 36, where did this come from? 36 comes from the radius value being squared. And that gives us the total area of 715 and 9200ths square units. Let's take a look at a couple of other examples. Example number 2, we have our shape is sitting very nicely on its base. Yay! So I'm going to go ahead and highlight my bases and do all of my labeling. I have a measure of radius, so this is ready for me to be used in my calculation. Let me zoom in a little bit. And so labeled my bases. That means the 7 centimeters is my height. I'm ready to put all of this information to work. Lateral surface area would be 2 pi r h. What am I doing with those 4 values? I'm going to multiply them. Plug in. In the same order that you're seeing. When you multiply, you definitely can do some shortcutting. You could say 2 times 2.5 is 5. 5 plus 7 is, 5 times 7 is 35. 35 times pi. That could be the one that you truly doing the calculation for. And so lateral area would be 109 and 9/10 square centimeters. If you are not asked about lateral area, in all of these examples, they're asking you to do both. In some situation, you might be asked just to find the total surface area. So you would write out your formula. And of course, before you do anything, before you check your work, before you do any calculation, plug in your values. Please do not shortcut. Do not rush through this process. And when we multiply across and add in these values, we're going to get the total surface area equaling 149 and 15/10, still square centimeters. So no guesswork. Plug in the values in, and they're going to be ready to go. So next, let's take a look at question number 3. So this is a little bit of an exposure to word problem. We do not have an illustration. That's what I like about this particular question, that you are not given a picture. So let's make sure that you create one. It doesn't have to be pretty, but I want to make sure that you're understanding what information you're working with and what information you might need to determine. So we have a cylinder with a diameter of, all right, so diameter, so measure the diameter is 21 inches. And then the height is 15 inches. All right, so that's how the picture would have looked if somebody else had drawn it. All right, I have everything ready, but not quite. I don't want to have the diameter measure. So I'm going to go ahead and adjust this because I need to have radius in my calculation. So I'm going to go ahead and do this. Definitely suggest for you guys to do the same to have all of your work ready to go. And let's get started. Lateral area would be 2 pi r times height. 2 pi 10.5 times 15. This product is going to give us the final answer of 989 and 1/10 square inches. Okay. For the total surface area, the process is very similar. It's lateral area plus 2 areas of circular bases. We are definitely welcome to copy the answer right here like we did earlier. So I am copying this down, but you definitely can say, well, yes, can I just add 989.1? Absolutely. Woo, lots of fill in the blanks right there. Quite an expression. So when we multiply this across, you will have 1,681 and 47/100 square inches. How do I know my rounding? I am making sure that I did read. It says nearest 100. So if it gets a little long, you can just simply round to nearest 100. So at this point, I would like for you to pick 1 or 2 of these shapes to work with. And so what I am going to do, I am going to give you the answers to these lateral and surface areas. So part of the challenge, I would like for you to pick 1 or 2 of these shapes and see if you can find correct lateral and total surface area. Please feel free to ask me questions and reach out for help. At this point, I'm going to go ahead and simply write down the answers that you should get, and hopefully that will encourage you to truly work them out and see if you are getting these answers correctly. And if you're not, this is again a great opportunity to ask for help, to reflect, let me see your work, and help you determine what you are missing.